Welcome to the next part of your lesson for 3.4. These questions involve word problems. Everyone's favorites. We love them. Yay. So let's just take a look at the question. Pause the video right now, read through it, and we shall resume. Okay, so we know so far that Melissa has walked a total of 3 miles to the house of a friend and returns home on a bike. So the distance to the friend's house from their house is not any different. So we know the distance is the same. We also know that on the bike, they're going to go faster, 4 miles per hour faster when they're cycling. Now, we also know one other key piece of information which is really useful, the total time, which is 2 hours. Now, there's a couple of things to note. Because we give you this equation, the relationship of distance equals rate times time, I'm going to want to be able to come up with an equation that I can use to model what's going on here. So let's just talk about what happens if we're walking. When we're walking, and I'm just going to draw a generic direction, we're going to walk to the right. We know that the distance they traveled was 3 miles. We don't know how long they took to travel the first time, so the time going one way, still no idea, but we know that whatever rate they're walking at, it's going to be X miles per hour. The other thing we know is when we're going the opposite way, when we're going back, we are biking. We're still biking, however, 3 miles, which is actually really useful for us. Yes, we still don't know how long it took to bike, but we know the rate was faster. We know that it was the walking speed plus 4 miles per hour. So it was 4 miles per hour faster. Now, this is the kicker here, because when they tell us the total time, total is a huge indicator for adding. So what we're saying is that together, my total time came out to 2 hours. That I know for sure. We just finished learning about rational expressions. So I'm going to create a rational expression relating time. I'm going to talk about 2 different times. We're going to talk about the time that it took for Melissa to walk. So I'm going to call that T sub W, just a subscript, it's just a name, plus the time it took for her to bike. Together, those times are going to equal my total time. So here's how we create the equation. I'm going to start off with my distance equation. We know that the distance was 3 miles, equals my rate of walking, which is X. Again, I don't know how long it took for my time, but we're going to call that TW, the time for walking. If I want to get the time for walking by itself, I just need to divide both sides by X. So TW is going to be 3 over X. All right, not too bad. We're going to actually do the same thing for the bike. So on our bike, we're going to have, again, the same distance, 3, but our rate was X plus 4. The time, again, we don't know what it was, but that's my time for biking. Again, we can get the time for biking by itself and say that that's 3 over X plus 4. Now I have all the expressions I need, and I have everything primed and ready to go. So here we go. I'm going to change TW to 3 over X. I'm going to change TB into 3 over X plus 4. And then capital T, which is our total time. Remember, we said that that was 2 hours. So now we have a rational expression that we can work with. Same thing as before. I'm going to find my GCF, which is going to be X times X plus 4. And we're going to multiply it straight into the equation. So when we multiply it to the 3, the X reduces. We're going to be left with 3 times X plus 4. When we multiply it to the second one, the X plus 4 reduces. So we're going to be left with 3X. and that's going to equal 2 times both terms. Nothing reduced here, unfortunately, but that's okay. This isn't going to be anything super, super crazy. This is something that's totally doable. So we're going to have 3x plus 12 plus 3x equals 2x squared plus 8x. Now you'll notice that we have an x squared term, which means we're probably going to have to factor. So let's go ahead and move everything to the other side. Let me actually combine like terms first before I do that. So I'm going to have 6x plus 12 equals 2x squared plus 8x. So now subtracting 6x and then subtracting 12, we are going to have 0 equals 2x squared plus 8. Oop, I totally went too fast. 2x minus 12. Now from here, we do need to be a little careful because you might be thinking, oh, I need to multiply the negative 12 and the 2, and then I might need to do some factoring thing. Notice that all of your terms are even, which means that we can divide them all by 2. Now, really, I'm not factoring it because I'm solving it. I'm just going to get rid of it entirely. So dividing everything by 2 is going to leave us with 0 equals x squared plus x minus 6. And this looks a lot nicer to factor. So we're going to end up with x, what does that get us? X plus 3, x minus 2. So you'll notice our two solutions is x equals negative 3 and x equals 2. However, you'll notice that since it's a word problem, we're probably not going to be dealing with a negative rate. I don't think Melissa is going to be walking backwards for the sake of this problem. So negative 3 is not an answer I can work with. So x equals 2 has to be our solution. So we're going to say Melissa's walking speed is 2 miles per hour. And we can just abbreviate that. Now, I'll admit, that was quite a beefy one, but we won't have to do too many of these. You just have to make sure you know how to relate your distance equals rate times time. So don't overthink those too much, all right? Let's take a look now. Again, giving you some time to pause. Let's take a look now at a different one. So let's talk about a very common problem. If you've ever seen Rookie of the Year, this equation has been used in the movie. When we talk about rates of work, this is actually a very general formula that we can use, and we kind of ended up using something similar on the previous one. But this one, again, I'm going to show you the cheat code for this. So we have 2 different people that can mow the lawn in 2 different rates. So obviously, if the 2 people are working together, they should be able to do it in less time. How much less time, though, is going to depend proportionally. So the way this proportion works is we say that, hey, for one job that I'm working on, Jack is going to take 40 minutes. And that same job, John is taking 60 minutes to complete. And together, hence the plus, they both complete one part of the total time. And that is the cheat code for being able to solve this. So now we're going to just simply set up our equation using the common denominator. Well, the common denominator between 40 and 60 is not 240, as some of you might have thought. It is actually going to be 120. I'm going to go with the smallest number that goes into both or divides evenly by 40 and 60. So I'm going to multiply everything by 120. Multiply it across. I'm going to write the work and then show the reduction. So 120 over 40 plus 120 over 60 equals 120 over t. So now 120 over 40, that reduces to 3. 120 over 60 reduces to 2. Then 120 over t. Now 3 plus 2 is 5. So 5 is going to equal 120t. And guess what? Now we have a nice two-step equation. I'm going to multiply both sides by t. So then we are going to have 5t equals 120. Divide the t on, divide the 5 on both sides. I'm getting tired, y'all. So then we're going to have that the time it took to be 24 minutes. So anytime you're given rates of how people do these types of work problems, this is the setup you do. 1 over the rate it takes plus 1 over the rate equals 1 over the time together. Now I say rate, right? But even though it's time, that's just like my rate of how long it takes to complete one job. So that's why we can say rate. So that was probably one of our easier ones. I'm going to show you one more example, which is going to be kind of, I don't want to say it's like one of the harder ones, but it's more one of the ones that can get a little involved. So for this one, you will want to make sure you write maybe a little smaller because we are dealing with thousands in terms of the numbers. So take a second to read what's going on. Pause the video now, and then hit play when you're ready. All right, so what's going on here is that we have a couple of scenarios initially happening. So initially, we don't know how many people have pulled together for the purchase of this yacht. But we know that we would divide the cost evenly amongst X number of people. But what happens now is that when one more person joins the group, we've reduced the cost for everyone. So we've taken away the cost of $2,500, and that's going to now equal the new cost. So the new cost, remember, is still the $50,000, but now you're dividing it by the one more person that's there. So if you had X people before, and you have one more person, well, now that becomes X plus 1. So now this is our expression. So we should hopefully now see that, okay, we have to get rid of the fractions by multiplying by the GCF. So like I said, the numbers themselves aren't bad. They're just, numbers with a bunch of zeros. So they're gonna take up a little bit of space. So like I said, maybe start writing a little smaller from here on out. But here we go. So when I multiply the x times x plus 1 to the first term, the x reduces. So I'm going to be left with 50,000 times x plus 1 minus 2,500. There was no denominator that reduced there. So we're going to multiply that by x and x plus 1. You can tell I'm getting tired because of how late this video is going. Equals, and then the last term, the x plus 1 reduces. So we're left with just the x there. So now let's distribute the 50,000. So 50,000 x plus 50,000 minus 2,500 x squared minus 2,500 x. And then we're going to set that equal to, again, our 50,000. Now, at this point, and actually probably early on, I probably could have reduced all of my numbers. I'm going to keep them till the end and then reduce it just because I guess I like to torture myself. I have no idea. But let's see here. It looks like that we have a leading x squared term. It looks like we have two terms that have x's on them. And it looks like the 50,000 is all by itself. So we're going to combine like terms and rearrange some stuff here. So let's go ahead now and say then that we have negative 2,500 x squared plus 47,000. I know how to write, y'all. 47,500x plus 50,000 equals 50,000x. Okay, now I do have more terms on the left-hand side. Even though my leading term is negative and I've told y'all to move it to the other side, I'm going to actually move the 50,000x over. And so our expression is going to come out to negative 2,500 x squared minus 2,500x plus 50,000 equals 0. Now, we did something kind of similar to this, where we divided all of the terms and reduced it. I believe it was up here in our word problem, right? Everything here was divisible by 2. I know it's like weird. Yeah, everything here was divisible by 2. So everything in this word problem is now divisible by negative 2,500. If I can reduce the negative on my leading term, I'm going to do it. So reduce out negative 2,500. Oh my goodness. From everything. So then your expression is going to now simplify into x squared plus x minus 20 equals 0. I realized I didn't write a negative there. There we go. Now, that looks way better. Way better on the factoring. So we're going to get x minus 4 times x plus 5. And we're going to set that equal to 0. So our two solutions are x equals 4 and x equals negative 5. Now, considering the nature of the problem, if we're talking about how many people were in the original group, I don't think we're going to have a negative person. You can have negative Nancys and all that jazz, but we're not going to have a negative person in the group. So there were originally 4 people in the group. If the question asked you how many people were in the new group, well, the original group was 4 because that was x. So x plus 1, I would then answer that there were 5 people. But yeah, so we can say 4 people in the original group. All right, so those were the different word problems that you'll have. Again, I went over one of each kind to make sure you had some variance, some variety in your examples. Make sure, again, write down any questions that you have, like, Mr. T, how'd you do this? Rewatch them if you have to. Hopefully I explained everything in a way that you could understand. But yeah, that's basically it. So I'll see y'all when I get back. Have a great weekend, and I'll catch y'all on the flip side. Bye.